Good afternoon, everybody. Welcome to the Johnson Space Center and this update on the progress toward launch of Discovery on the STS-121 mission. Joining us today is the program manager for the Space Shuttle program. That's Wayne Hale. He'll give you all the details and update on the preparations ongoing, and then we'll take questions from NASA centers. We also have a phone bridge, and we'll take as many calls as we can, questions from that. As we have time allotted. We do have to finish this briefing by the top of the hour at the latest, so we may not get up to everybody, but I can assure you that you will get the information. And with that, I'll turn it over to Wayne.
Thanks, Kyle. Good afternoon, everybody. Thank you for being here. We had an interesting set of meetings over the last couple of days, and I have made some decisions just today about 2 o'clock this afternoon that we thought would be good to share with you. We have been watching a problem, as you know, with our low-level sensors, what we call our engine cutoff sensors, go by the acronym ECO sensors, in the external tank. If you'll recall from last summer, we had a couple of problems which caused us a great deal of wonder about what was going on with the system that tells you when you're about to run out of fuel in the liquid hydrogen tank or the external tank. We kicked off a large investigation after the events of last summer. The NASA Engineering and Safety Center participated very heavily in this investigation, as did the external tank project at Marshall Space Flight Center Engineering. And during the course of this investigation over the last several months, they found that there may be a problem in manufacturing some of these sensors. And that problem is in the way the wires are attached to these low-level sensors. And you're going to pardon me because I'm going to go low down into the technical here, and we'll come back at the higher level in just a minute. There is a place that the wires attach to the sensor. It's called a swage fitting. That swage fitting in some sensors that have been removed sometime back in the history of the program has been noted to be a little loose, and that's caused intermittent readings of varying resistance in the sensor, which of course is how the sensor tells you whether it's reading a dry or a wet signal. Last year, when we prepared to launch STS-114, we had a high degree of confidence that the sensors would only fail if they were to fail in the wet reading condition. After a lot of work, there's now some body of evidence that would indicate it's possible for the sensors to read erroneously dry when the tank is not in fact dry. A predecessor indication that something may be going on in the sensors is an increase or a shift in the resistance over time, particularly after the tank has been transported, vibrated, rattled around a little bit. We in fact have a sensor in the external tank that's slated for the next flight that is showing a very small shift in its resistance reading, well within any previously established specification reading. However, because of the new knowledge that we have this year and the ongoing engineering work that's looking at how these sensors work and how they may potentially have problems, we are taking the step of removing the external tank cutoff sensors from the bottom of the liquid hydrogen tank from the tank we're going to use for the next space shuttle flight. This decision was not an easy decision. It's always interesting. There are pros and cons. I told my team today, and we had quite a large team involved in the teleconferences for the last 2 days looking at this problem, that it's very pleasant to me that we have such a strong group of folks that can make all the easy decisions and make all the moderately hard decisions and only bring me the very few decisions that remain. So we had, as you might expect, quite an interesting debate, pros and cons, looked at every possible way around this, and finally concluded that it was far smarter for us to be conservative and take the safe route and replace the sensors that are in the tank. That will take us about 3 weeks of work, and that, of course, will move us out of the May launch window for STS-121. So today we are proposing that the no earlier than launch date, the earliest possible launch date would be July 1st, which is based on lighting. We in fact will be ready, we think, with the vehicle before July 1st, but we are dedicated to launching in the daylight so we can watch what happens to the external tank and the rest of the flight vehicle during the daylight for at least 2 more flights, STS-121 and the subsequent STS-115. And so we are aiming now for July the 1st. The team has been working very hard. We've worked folks, particularly those folks at the Michoud Assembly Facility that have been preparing the tank very, very diligently and very hard to get to potential to launch in May, and we wish it had worked out differently, but it's of course first and foremost that we fly safely. We want to have a good attempt when we fly in July or whatever date it is, and so it was prudent to change these sensors out and take the time to do this work. We did discover this reading shortly before the tank was shipped from Michoud, and we did have a discussion about whether it would be advisable to replace those sensors at the factory, and due to the fact that those sensors are most easily changed when the tank's in the vertical position, it was generally agreed at that time that if change-out were required, it would be better to do that at the Kennedy Space Center where the tank's in the vertical position in its checkout cell in the vehicle assembly building, rather than to do that at Michoud. And of course, the engineering work was still in debate for some time until we made the decision today. Folks that will be doing the work are workers from the factory, Lockheed Martin's factory at Michoud, coming from New Orleans. They will be traveling to the Kennedy Space Center where they will be entering the tank from the bottom. There is a large manhole cover on the bottom of the tank. They'll remove the foam insulation, remove a number of bolts to take the metal parts apart, and then they can enter. There are plenty of work platforms in the area. The access is quite good. Going to the tank, removing the sensors and replacing them with new and I would say much better screen sensors so that we will not have the potential of having this same problem to the best of our ability on new sensors, newly manufactured sensors, and then backing out of the tank, closing it back up, reapplying the insulation to the bottom of the tank. All are standard processes using standard tools, will be done by the people that normally do this work at the factory at Michoud. We hope to take the 4 sensors that we'll take out of the external tank and put them in an extensive test. We want to see if the one sensor that's got the slightly elevated resistance reading really has this problem that the engineering tests say it could potentially have. And then, of course, we will look at the other 3 sensors, which were manufactured about the same time in the same facility. We have a number of these sensors in tanks that are still slated to fly. The sensor in question was made 10 years ago in 1996 and passed all its acceptance tests, and in fact appears to have shifted in its reading, not this time when it was transported to the Kennedy Space Center, but when it was transported last summer before STS-114 to the Kennedy Space Center. Let's see, what else can I say? We're all very optimistic that we will be able to wrap up the rest of our work. You know, we have a number of other challenges ahead of us that we're going to be tight on the schedule to get done to support a May window. This additional 6 weeks that we will now have should provide us plenty of time to wrap up our work on the aerodynamics, looking at the airflow over the tank after removing a lot of foam and the protuberance airload ramp area. And I think we'll be in good shape to look forward to a launch about the 1st of July. The folks are off evaluating at my direction this afternoon. Subsequent launches, I really don't have anything to say about that other than I remain optimistic we'll still be able to get 3 missions in this year, but I don't have the details on where we will fly the next 2 missions later in the fall, I'm sure, and we will have those data for you in another week or so, I think. So with that, I guess I'm ready for questions.
Okay, let's limit it to one question apiece, please, and I'll get to as many people as I can. And I'm not choked up about everything you said, by the way. We'll start with Craig.
Craig Cavall, Aviation Week. Wayne, what is the increased processing rigor, inspection rigor that will be put in place? And were there any pre-Columbia mission sensors that flew that had this, even the subtle characteristic that documentation has turned up?
Indeed, we looked at the entire family of sensors that were made in that calendar year. There was, we think, some concerns with the device that makes this electrical swage connection that have subsequently been corrected. Out of the about 400 sensors that were manufactured in that calendar year, there were 10 or 11 that were removed during the build-up, after they had been accepted, after the sensors themselves had been accepted, but during the build-up of the tanks that were removed, some of those did show a loose swage connection. We also flew at least 2 sensors in that group of family. Of course, flew them a couple of years later in the 1999 time frame that did in fact show small changes in resistance that operated perfectly normally. So what we have here is an indicator. It's not a guarantee. It's entirely possible we could pull the sensor out and it will be perfectly fine. But we think we have enough of an indicator that says we ought to go take a really hard look at this and make sure that we've got a really good set of cutoff sensors, because after all, that is a critical function, and we want to be safe when we fly.
Go ahead, Guy.
Guy Galliotto of the Washington Post. Is this a design flaw, Wayne, or is this something that happens to particular sensors in a particular lot?
I would say that it's hard to characterize. I would say that this particular way to make electrical connections is a difficult operation. And so there is some talk of potentially changing the design. I would also tell you that these sensors are sensors that are manufactured in the same way by the same folks, are used in a variety of programs. They were used on the Saturn launch vehicles. They're used in the Delta, some of the Delta launch vehicles, and the other expendable rockets. So this technology is not a really new technology. It has been robust over the years. But again, it shows the level to which we take safety in this program to make sure that we're going to fly with a good set of sensors.
You have a question, Laura?
Yeah, Laura Whitley from KTRK-TV. Wayne, could you explain why the decision to push back the May launch date is such a painstaking decision, why that's so hard for you guys?
Well, again, the decision that we made today was not based on schedule. Let me make that very clear. The decision that was difficult for us was because the evidence is not black and white. There are indications in some engineering tests that indicate we've got a concern on the one hand, versus the fact that you have to go into the tank, you have to open it up, take the pressure seals apart, take the insulation off, go inside of that tank, change electrical connections, and then back out and button everything up. There are certain risks involved that you could damage the tank, and so on and so forth. So when you look at it as a risk, what do we know about the sensors and what is the risk there, versus the risk, what do we know about the work to change the sensors out and what is the risk there? And we made the decision based on the relative risk, quite frankly, of those two operations, and then the schedule fell out where it was. So this was not a discussion about schedule. This was a discussion about safety, and we came down on the side of doing what's right to make sure we have a pristine tank, and we'll be ready to go fly safely when that tank is ready to go fly, as we do with all our equipment.
Irene and then Mark.
Hi, Irene Klotz with Reuters. Wayne, where do things stand on the wind tunnel tests with the foam? Have you learned anything yet? And also, do you know the name of the manufacturer of the echo sensors?
You know, I should have gotten the name of the manufacturer before I came over here. Is that we had a discussion last year, and there's a couple of companies that have the similar name, and I don't want to put the wrong name out, so let us make sure we get the right name. And I want to also hasten to add that this is not a shortcoming on the manufacturer's part. This is a precision part, and in any normal kind of industry, the failure rate would clearly be well within what consumer electronics or anything would allow. This is a very reliable part, and we believe that, if anything, the manufacturer has improved the process over the years, and they're making them better now than they were in years before. So don't take the wrong message from this discussion. Wind tunnel test, thanks. Changing gears a little bit, one of the things that we have done to improve safety with the external tank is to remove about 40 pounds of foam off the outside in the protuberance air load ramp area. Those wind deflectors on the outside of the tank protected the cable tray and pressurization line that runs up the outside of the tank. We have started the wind tunnel test. We've got wind tunnel tests running specifically at Ames Research Center and Glenn Research Center. The Glenn Research Center wind tunnel is a 50% scale model of a small portion of the tank, and the Ames Research Center has got a 3% scale model of the entire shuttle launch vehicle, and both of those tests are in progress. The Ames tunnel went supersonic for us just the other day. The results are coming in, and the engineers are poring over them. And I would tell you, there's one thing certain about wind tunnel tests, is that the data have to be interpreted. In the early results, I don't have a very good handle on, but they are proceeding, and the engineers are looking at the data, and I expect to get a report shortly on some of the preliminary data. But the good news is we got the models fabricated, we're in the wind tunnels are operating, and we're gathering the data we need to make a good determination of the safety of the new design.
Mark Carreau from the Houston Chronicle. I had a question about how the sensors work in concert with the flight controls. If you could just sort of explain the main mechanism that shuts off the main engines is not the sensors, as I remember. It's more of a backup mode, or could you just sort of explain the critical nature of this hardware?
Well, just like in your car, you don't want to run it until it runs out of gas. That's not a good thing. So you'd like to get where you want to go before the tank is completely empty. So the normal planning for a mission allows us to achieve the right orbital conditions, altitude, speed, direction of travel, without running out of propellant. In fact, we load extra fuel on board to make sure that even if we have small variations in the performance of the vehicle during launch, a small reserve is there to make sure we get to that point in the sky without running out of gas. And as a result, when we jettison a tank, we always throw away some amount of liquid hydrogen and liquid oxygen, which comes in with the tank and is disposed of in the Indian or Pacific Ocean. The sensors are there in case we have some kind of performance problem, which we have had twice in the history of the program. First kind of thing that can happen to you if you have an inadvertent or a premature shutdown of one of the main engines. Then the other two engines have to work longer and use more gas to get where you want to go. We had that occur to us way back before, well, it was in 1985, STS-51F. Very clearly remember that flight. Had some problems with a totally different kind of set of sensors that monitors the performance of the engines, and erroneously shut the engines down, shut one of the engines down based on some erroneous sensor data. The engine was perfectly fine. We've since gone to a great deal of effort to improve those sensors, by the way. But because of that, we did run out of gas before we reached the orbital altitude that we wanted, and the sensors were there to shut the engines down safely. The second flight that we had an occurrence on was STS-93, the delivery of the Chandra Space Telescope to orbit back in 1999. If you'll recall, we had a problem where we had a little hydrogen leak out the cooling tubes of the engine, plus a couple of other things that happened ashort that caused us to disqualify half an engine controller. So we had some shifts in performance and came up just a little bit short, just a fraction of a second short of where we wanted to be in terms of engine burn time. In both cases, the sensors through the onboard computers correctly told us that the tank was dry, we were out of fuel, and we should shut the engines down. You like to shut the engines down with just a little bit of gas left in the lines to make sure that those pumps that pump the fuel and both the hydrogen and the oxygen into the engines don't cavitate as they spin down. That's not good for the engines, and it can lead to a number of problems. So we have in place these sensors on both the fuel side and the oxygen side to let us know before the engines actually don't have any gas left. The tank may be empty, but before, while there's still gas literally in the line, to shut the engines down so that it's a safe shutdown. That's what they're there for. And there's quite an elaborate logic scheme to make sure you do it at the right time and not at the wrong time. And a quad redundant, there's 4 of these sensors, they vote to get that indication.
Okay, let's go to the Kennedy Space Center in Florida for questions there.
This is Kevin Oliver from WFTV in Orlando. Wayne, can you just run through some of the risks you run by going into the tank while it's here at the Space Center?
You know, the principal risk that we run by going into the tank is the risk of hardware damage to the tank that would make a more different kind of repair, say on the seal around the manhole cover, something like that, that would cause a schedule risk. Whenever you put a person inside the tank, they're in a confined space, and there is clearly a hazard there, and they've got to be provided with breathing air and closely monitored. Folks will be going up on scaffolding. That's also a personnel hazard. It's something they do in the normal course of business, both at the Kennedy Space Center and at the Michoud Assembly Facility. But anytime you do that kind of work, you take certain kinds of risks. The kind of risk that I want to tell you we're not taking is a flight risk, because we think that anything that might not turn out in this repair would be detectable by us before we close out the tank, so that when we go to fly, it will be a good tank. So really what we're looking at are 2 sorts of risks: damage to the hardware that could take us longer to fix than we anticipate, and we think that's very low, and then personnel hazards, as I described, which we have a large amount of safety processes in place to keep from hurting anybody.
Todd Halverson of Florida Today for Wayne, obviously. Are the sensors on the 119 tank from the same manufacturing lot as the sensors that were on the ET-120? And is there any reason you guys didn't swap out the sensors in ET-119 after the trouble cropped up on STS-114, or were new sensors not available? I'm trying to get a sense of your decision-making process on this.
Well, the sensors aren't made in lots, so we're looking at calendar years at this point of when the sensors were manufactured. Again, there are some tooling things that were going on in the 1995-6 time frame that have put a little shadow on the sensors that were manufactured then. So the sensors that are in ET-120 that you'll recall we tanked twice and sent back to the factory, as well as the sensors in ET-121 that we used for the mission last July, and the sensors that are in this tank that we now have at the Kennedy Space Center that we're planning to use for the next flight, as well as other tanks. We have those sensors, and they're common in these tanks. What we have learned in the year, well, 8 months since we flew, is a better understanding of how these sensors work, and the indication that A small shift in resistance could be indicating that we might have a problem with the sensor. We don't have any of those shifts in resistance indicated on the next tank that we've got. We don't have any shifts in resistance indicated on 3 of the 4 sensors in the current tank. And in fact, I should tell you that on ET120, where we did have some erroneous reading from the system. Now remember, it's not just the sensor, there's wires and connectors, and then you get to the orbiter side, there's more wires and connectors, and finally you get to this electronics box that tries to make sense out of the resistance reading. We still do not have a good and complete resolution to what caused the problem that we saw with ET120. Now, I will tell you that we are in planning to go into ET120, which is currently back at the Michoud assembly facility, and pull out those sensors and look at them. Clearly, something happened during our tanking test with that tank that caused the sensor on the first tanking test to read erroneously. And when I say sensor, I should say sensor system. Again, we don't know where in that chain the erroneous reading occurred. We want to pull those sensors out of the tank and look at them very closely. Right now, they don't show any resistance changes from when they were manufactured. So again, we have a suspicion and some body of evidence, and we'd like to get clear of that, but we're going to be removing those sensors and looking at them over the next couple of weeks as well.
Okay, we're done with KSC. Now we have the phone bridge, and this is similar to a normal media telecom that we would do if we weren't on NASA TV. So *6 mutes and *6 unmutes your phone. We'll go through as quickly as we can. I doubt we'll get to everybody, but we'll start with Warren Leary. Hopefully, Warren, you're on the line.
Warren Leary, New York Times, Wayne. Other than waiting for the wind tunnel results on the phone, what does the extra time give you in terms of other preparations for this flight? What would you be able to do, let's say, at a more leisurely pace than you would have going from May?
Well, there are clearly other engineering topics under investigation. They will be in their investigation every time we go fly. This will give us a chance to get a little further down the road on some of those topics. We've been interested in changing out some of the outer window panes on the orbiters. This is going to give us a chance to do some of that work. As you know, we've been removing and replacing gap fillers between the tiles on the orbiter. This will allow us time to do even more of those if we determine that's necessary. There are any number of aging aircraft issues that we have tests in progress that we think are going to turn out in our favor, but we'll certainly keep an eye on any of them. There's always a challenge in the space business trying to keep up with all of the technical things that you'd like to do. There are proposed improvements in the system we'll continue to look at. 6 weeks is not a long time to make a huge number of improvements, but if one of those comes along that we can make, we certainly will.
Dan Billow. How about Bill Harwood? Let's see, Tariq Malik, are you on?
Yes, I'm here. Thank you. Tariq Malik with Space.com and Space News. Wayne, I was just, curious. You mentioned that you have plenty of time available to kind of get the other things out of the way and have the orbiter ready to fly in July. I guess, is there a break then in that time? I mean, will you have an extra week kind of in that schedule to get stuff finished? Is there even 2 weeks, I guess, in that 6 week period? I guess, what's your projection there?
Well, we were racing very hard to get to the mid-May launch period, and this extra 6 weeks, obviously the folks working on the tank will be continuing to work, but I would expect it would allow us to slacken the pace in other areas, perhaps not work overtime that we were intending to work, perhaps allow us to take some weekend days off that we were planning to work. All of that is under assessment at the Kennedy Space Center.
Let's see, Chad Murray, are you on the line? How about Ned Potter? How about Mike Cabbage?
Hi, Mayor.
Okay.
Wayne, I wanted to follow up on one of your earlier answers. Do you see no relationship between the problem that you've found here with the manufacturing issue and the anomalies that happened last year during the tanking test and the countdown, or is there some way they could be interrelated? As a second part, a real quick question, what's your latest on what the July window is from when to when?
Well, let's see, the July window extends from July the 1st to the July the 19th. There may be a day or so on either end of that, depending on the orbital altitude of the space station and how that affects lighting. But you can, I think today's calculation is July 1st to the 19th. You know, the jury is still out. I would not tell you we've conclusively proven that this swage connector issue is what caused the problems last summer. There are a number of potential areas that we identified in the fault tree that could still have caused those problems. We have been planning a full systems test where we take an end-to-end system and put it on a laboratory bench. That's everything, the wires, the connectors, the point sensor box, the sensors themselves, and subject it to some laboratory testing. We may yet do that. I think a lot is going to depend on what we see on these sensors that we pull out of the tank that's in Florida now and the tank that we had the problem on last spring and had back at the manufacturer. We've been concentrating, I might add, on that ET120 tank that's back at Michoud on the foam applications, and so we have put a lower priority on the engine cutoff sensor, but it's been on the list of things to do. As I said, we always can come up with more tests to run, and we will get to those in due time. Yeah.
How about Mike Schneider with Associated Press?
Hi, Wayne. How does this decision affect what will happen to Discovery's robotic arm? Will it be replaced or repaired? And then also, if you could just talk about the schedule for the rest of the year. I guess the next two opportunities are still going to be August and November.
Well, let's talk about the arm a little bit. You know, we had an unfortunate incident that caused some damage to the robot arm that's on Discovery. We have, I think, already pulled that arm off. If not, it will be in the next couple of days, but I believe it's off already and back in the shop there in the VAB to be looked at. We've determined that the best way to fix that arm is to take the graphite epoxy boom section out and replace it with a new one. That process takes a couple of 3 weeks. We have the arm that was taken off Endeavor, which is in depot level maintenance, that we can put back on. The interesting thing about the arm that was damaged was we had special instrumentation for some tests that we wanted to run on Discovery's next flight. They were not mandatory tests, nor is the instrumentation mandatory. There are improvements nice to have, cut down on the uncertainty of the test results. So preliminarily, we thought we would use Endeavor's arm and go fly with that arm. Now, given a few more weeks, we're going to take a look at the schedule, and it may be that the repaired arm that came off Discovery and has the special instrumentation may in fact go back on Discovery. And that work obviously is being thought about right now. We've got a lot of folks looking at schedules in various areas and how best to make use of our time.
Let's see, Jay Barbary, are you on the line? How about Kelly Young? How about Bruce Nichols?
I'm here, but I have no questions, thanks.
Thanks, Bruce. Jeff Morris at Aerospace Daily, are you on? How about Mark Kirkman?
Yeah, I'm on. Can you hear me?
Sure can.
Yeah, Mark Kirkman with Interspace News. Wayne, some of us are late getting to the phone grid, so you may have covered this. Are you going to stick with 4 for the Washington criteria with regard to the sensors? And also, what's the status of the 2 SPS issues we discussed a week or so ago, the pre-valve screen and the seal? Are you apply as is, or time, now that you have it, to maybe go in and take care of those? Thank you.
Thanks. Well, let's see, there are 3 or 4 questions there. Pre-valve screen cleaning is still under discussion. That has not come back to the program management for resolution. There were a number of tests that were being run. You know, all these issues, so you find a problem, you go do some testing or some analysis and come back, and we'll either do or not do additional work based on that. And I would say that is that's a very similar kind of discussion, and we'll make that based on the risk versus risk of going into the aft end of the vehicle and opening up that complex set of plumbing that we've got for the main engine system versus the risk of whatever small particle impact might cause us there. So that story hasn't come back to us. The engine seal story is coming together. We have replaced a couple more seals, and we believe we've got good seals in 2 out of the 3 engines. They're still looking at, I think, 1 or 2 final seals in the first engine that was installed. It's not leaking, but they didn't measure the seals in exactly the right place. So there's some discussion about going ahead and changing those out to make sure that all our seals meet their dimensional requirements. You know, we leak check those joints at normal ambient temperature, but those pipes carry cryogenic fluid, and it causes considerable thermal expansion, contraction, really contraction in those areas. And so there is quite a bit of art of doing the analysis to make sure that just because it doesn't leak at room temperature, it won't leak at cryogenic temperature. And I think we're about to wrap that up. There may be 1 or 2 more seals left. But if we need to, we'll change those out. And if not, we will fly with what we've got because they're not leaking right now. And there was another part to your question. I'm not sure I remember what it was. 404. Oh, the launch commit criteria. You know, we had a long discussion about the requirement for 4 of 4 of these sensors. In the early days of the program, there was, in the design phase actually of the program, it was recognized that you really need 3 sensors. I mean, you need 2 fault tolerance in a critical piece of avionics. So if 2 of them were to fail and you still need the function to work, you have to have 3. I mean, that's the basic mathematics of redundancy in the shuttle world. And they also, at that time, recognized that perhaps the system, and not just the sensor, but the whole system, might not have the reliability that they really wanted, so they put 4 in, thinking you only needed 3. And in the early days of the program, we had a launch commit criteria that said 3 of 4 sensors is good to fly with. In other words, you could have a failure during the countdown and still proceed to launch. Sometime in the 1986-87 time frame, an analysis was performed that found a commonality in the power so that you could blow a fuse and lose a particular power circuit in the Space Shuttle orbiter that would take out 2 of the sensors. And all of a sudden, you no longer have a quad redundant, but you have a system that really is not as robust as you'd like. So they changed the launch commit criteria requirement in those days to 4 of 4, and it has been there ever since. During the downtime after Columbia, we approved the wiring change to go back and rectify that, so we no longer have a common power circuit that single failure can take out 2 sensors. And ever since then, we have been in discussions about this 3 of 4 okay to go back to. For STS-114, Discovery's last flight, we agreed to a 3 of 4 criteria in a very limited set of cases. Only the hydrogen sensors, only one of the sensors that we had previously thought we had problems with, and only if it failed in the wet reading direction. The discussion today with the new engineering data, we think that the sensors might actually have the potential to fail in the dry sensor reading. That puts a whole new framework to the discussion. We don't think we're quite as tolerant to dry failures as we are to wet failures. So we instituted that launch commit criteria change on the last flight, only for that flight, and only for a very specific small set of cases. We never instituted a generic, any 3 out of 4, any way you'll fly. We don't have any change to the 404 launch commit criteria currently in place for the next flight. Based on what we're learning, we're going to go off and talk about that again so that we understand where we should be on launch day, but as of right now, it's still 404. That's a long answer to kind of a short question. I'm sorry.
Let's see. Jeff Morris, did I already call? How about Justin Ray? Are you on, Justin? How about Emily Baser with USA Today? How about Nancy Holland? How about Alan Boyle with MSNBC?
Here I am. Can you hear me?
Yes, sir.
Wayne, I wanted to double check on a couple of questions, if you don't mind. One would be the procedure, just to recap the procedure for changing out the sensors. Do you have to take the tank to a horizontal position inside the VAB? And then the other, you made a reference to this mission and the next mission. Both those missions might be test missions. Does that mean that the construction mission goal will be changed or delayed?
Well, okay. Let's start first question. The actual change out of the sensors will be done while the tank's in the vertical, hanging up in the vehicle assembly building as it is now in what we call the checkout cell. However, putting the foam back on the bottom of the tank, it's preferred that that's in the horizontal position. So after we get done with the inside of the tank and have the new cover bolted back on, they'll actually pick the tank up and put it on the transporter in the transfer aisle in the middle of the VAB and apply the foam. And at that point, when they're done with the foam work, the insulation work, they'll pick the tank up from the transporter and take it right over to the integration cell, which is where the solid rocket boosters are waiting for the tank to arrive, and after that, of course, the orbiter comes. Okay, I'm having trouble remembering two questions.
The mission after this upcoming one.
Yes, it's not a test mission per se. In fact, STS-115, which will fly later in the fall, will be a construction mission. We're going to carry the next solar array up to the International Space Station as the current manifesting cargo. But what I did say was we do want to have a daylight launch to one more time look at particularly the performance of the tank, the entire vehicle, but particularly the performance of the tank in the daylight, to make sure we have two good launches with no significant, and we're going to have some small foam losses, but no significant foam losses that we should worry about. So we'd really like to get two daylight opportunities in. And I'm sure we'll have a discussion based on what we see after 121. We've got some new cameras. There are a large number of folks that believe that it's possible we could launch after dark because the brilliant light that's generated by the solid rocket boosters should illuminate the tank from below, and these new cameras are at a lower position looking up. That remains to be seen. Right now we have said we'd like to have daylight for both STS-121, the next flight, and the flight following that, STS-115. It is not, in any other respect, I think, a test mission. STS-115 will be an assembly flight.
Let's see, Pat Duggins with NPR, are you on? I hear somebody breathing. Who is breathing? I don't have you on the list. I don't have a breather. Let's see. Chris Dolmich, are you on with Bloomberg?
I am indeed. Can you hear me?
Yes, sir.
Okay, I guess, my only question, this may have been addressed earlier, Wayne, but I was just wondering, do you think with the schedule you have, the administrator thought it was possible to get in 3 flights this year? Do you think that's possible at all?
Well, I do think it's possible. We need to go work on the schedule a little bit and see how quickly we can get the vehicles turned around But I definitely would not take that off the table at this point. I still think it's entirely possible we could get 3 shuttle flights in this calendar year.
Let's see, Jim Oberg, are you on? Okay, I'm running out of people here. Let's see, Fanny Carter with AFP, are you on? Okay, is there somebody on that I called on or has not called on?
Can you hear me on now, voice?
Yes, ma'am, go ahead.
Yeah, hi, thanks. Could you describe a little more the different type of failure you all now feel that the sensor could cause? You talked about errors in the wet versus dry situations, but I'm not entirely clear on what this means in terms of a different type of danger that it could pose to the shuttle in case of malfunction.
Well, let's see. There's a couple of ways I could take that question. The way these sensors work, it's a ceramic square, hollow square, that has a platinum sensor wire zigzagged across it. I think we showed a lot of pictures last year. I'm sorry I didn't bring show and tell with me today. We can certainly dig some of those out. The platinum wire, the very thin, hair-like platinum wire, is very sensitive to temperature changes. It changes the resistance in that wire. When the wire is dunked in a cryogenic fluid, liquid hydrogen or liquid oxygen, the resistance in the wire gets very low. When the fluid no longer covers that wire and the temperature starts going up, the resistance starts going up. So there is an electronics box that looks at resistance and interprets whether or not the sensor is dry or wet. They were very clever when they designed this box some time ago, and I think the circuit design actually is an Apollo Saturn heritage circuit design. It says, however, if we know it's an open circuit, if there is extremely high resistance, it's not just dry, it's an open circuit, but we're going to declare that sensor wet because wet failures are more benign. In other words, we are not likely, as I described to you earlier, to run out of gas. We have put in extra propellant. We have designed our flights so that we have more hydrogen and oxygen in the tank than we really need to achieve orbit. And so we are unlikely to get to the point that you need to cut off the engine. So if a sensor is going to fail, if it fails to the wet state, that is probably benign. If you had multiple sensors fail to the wet state, of course, you lose the protection that you would like to have because they vote for shutdown. If they fail to the dry state, that's an indicator to the onboard computer software that we ought to shut the engines down. So there is less requirement, I guess you'd say it, in that you could be flying along perfectly fine, and if a number of these sensors fail to the dry state, it would shut the engines off early, prematurely, which is not a good thing in spaceflight. So from the potential to cause problems, obviously you want to shut the engines down if you're running out of gas, but you don't want to shut the engines down early if you're not running out of gas. It's kind of either way you can get in trouble. It is more benign to have a wet failure than a dry failure when you do the logic analysis. But neither failure is really what you want. We would like to have 4 really good sensors, wires that connect the sensors back to the orbiter, connectors all the way down those wires, point sensor box that interprets that. We'd like to have a good system when we go fly. And when you get right down to it, that is why we are going to change these sensors out, is to have the very best shot at having a very good system. Can't say perfect because nothing's ever perfect, but as close to perfect as we can get before we go fly. Because this is what we call a criticality 1, life or death kind of situation that you want those sensors to work properly either way. They can prevent bad things from happening. If they work properly, and they certainly work badly, they can cause bad things to happen. So we need to have a good set.
Okay, I have time for one more. Is Dave Waters on the line from Channel 13 down in Florida? Okay, one last chance. Is there somebody that I called on that wasn't on or that I didn't call on? Okay, sounds like we got everybody in that needed to. That's all the time we have, so I appreciate everybody coming and participating. Have a nice evening. Thanks.
That's all I want to do is I'll get my dad when I get the next door. So we started this. Really, the only spot you got to be careful is around the head.
You take the condensate off and then you sand it a little bit.
You're working around the bolts right now? Yeah.
And they're having a retard. Oh, yeah. Just that. It doesn't.
It does. No, it's pretty good. We can help do that. Yeah, we'll help. And the outer here left. Yeah, one type of tape we can use to match around half-back.
So 3 head long from the Minneapolis or the St. Paul is only about
your turn. You got one. More loosen? No, I'm not far side. Loosen his right where he's at. Take yourself into a hole there. Second room.
Good morning and welcome to NASA headquarters here in Washington, D.C. for today's Space Shuttle update. Today's participants include NASA Administrator Michael Griffin, Space Operations Associate Administrator Bill Gerstenmaier. From the Marshall Space Flight Center in Huntsville, Alabama, we have Space Shuttle Program Manager Wayne Hale and External Tank Chief Engineer Ken Walzen. Now we'll have some short opening remarks followed by some questions and answers, starting here in Washington first, and then we'll go around to reporters at the centers. As is customary, please identify yourself and your organization before asking your question, and also address whoever you're asking your question to as well. And as another reminder, please turn off all cell phones and BlackBerries before we get started. All right, it's now my pleasure to introduce NASA Administrator Michael Griffin.
Thanks, Ian, but with all due respect, I want us all to hear from first is Wayne.
Okay.
I'm primarily here for top-level issues, and if we get one of those, I'll handle it.
All right, Wayne, we'll go to you first, and let's hear your opening remarks.
Thank you, and good morning, everybody. I appreciate the interest and the turnout that we've had here to discuss the status of the Space Shuttle. And I want to start out by saying that we have celebrated the 25th anniversary of the Space Shuttle just a few days ago, and it's a remarkable thing to think about all of the folks that worked to design this incredible vehicle 30 years ago to its first maiden flight 25 years ago, and all the incredible activities that we have been able to do in space because we have this wonderful machine. But as you know, we do have a serious concern with debris, particularly debris coming off the external tank in the foam that can come off the tank. It was clearly something that we had not carefully considered before the Columbia accident, or as carefully as we should have, and we have spent this past considerable period of time working to make the debris situation, the potential for liberation of foam off of the tank, as small as we possibly can. I'm reminded of the words of Dr. Diane Vaughan, who talked about NASA in a book about an earlier problem that we had, that foam is, in her definition, an unruly technology. And what she meant by that, and what I understand that she meant by that, is that it is not well understood in the way that we understand metals and some other aspects of engineering. It is a science. The understanding of the mechanical properties of foam insulation is something that we are going to be working on for some time. What we have done in the Space Shuttle program is to take a look at our largest potential areas of threat from foam loss and attack each one of them. Clearly, the first area to work on was the 1.6 pounds of foam that we lost during the Columbia launch that caused that accident. We have eliminated the bipod ramps off the outside of the external tank so that there is no continued threat from that large piece of foam. We made improvements in a number of areas and then decided to fly what we've termed our first of two test flights, STS-114, to see if we had in fact done enough to mitigate foam loss. And as you frequently do in test flights, we found that there was another mechanism that we had not considered, another opportunity to lose foam that we should address when we lost a just over 1 pound piece of foam off what we call the protuberance air load ramp, the PAL ramp. And the past several months we have been working very hard to eliminate that ramp and make sure that we can fly without that large piece of foam. That change constitutes the largest aerodynamic change that we have made to the Space Shuttle launch system since it first flew. And we're approaching that with a great deal of care, doing the work necessary to prove that the aerodynamics will still be good, that we have not introduced a aerodynamic loads problem that could cause the structure underlying to come to grief. That is a very intricate process, and that still paces us for our next flight, and we will be working on ensuring that the removal of the PAL ramp was a safe thing to do almost up to the flight readiness review. We expect to have our final report out of the loads assessment people and the aerodynamics people just before the flight readiness review. At the same time, we know that past the power ramp, there is further work we would like to do in the tank. There is more areas where we have seen historically foam loss. And yesterday, I should say that we know the next largest area that we're concerned about is something called ice frost ramps, which I've got a model of and we'll talk about in a minute. And some months ago, we determined that if we were going to modify the ice frost ramps during this preparation for the STS-121 flight, that the appropriate time to modify those ice frost ramps would be the first week in May. Every Thursday, we have a programmatic review board, and we had penciled in some time back, April 27th as being the date that we would review whether it's appropriate or not to make a change to the ice frost ramps. We had that review yesterday. It was an outstanding review. It represented the culmination of work of literally hundreds of people, many tests, many designs. Some of you have been following the work that's been going on in the wind tunnels around the country, where we put some of these test articles to see how they will work out. And we reached a conclusion yesterday that it was a mixed conclusion, as many of the decisions that are brought to the program manager's desk are. There are folks that have opinions on both sides, people that have come from strong technical backgrounds and give me and the other management team great advice. And yesterday was a typical day in that we got some mixed recommendations and made a decision. Let me talk a little bit about what we've got. On my left, your right, here is a test article that's got one of the ice frost ramps in a test configuration where we've been using it here at the Marshall Space Flight Center to see the effects on the back side of this piece part model. Cryogenic liquids, helium, is normally introduced so that we can see how the foam will react to that, whether it will keep ice from forming, whether it will crack, whether other things might happen. These ramps are spread out over the tank. In the way of background, we have over 4,000 pounds of foam insulating the external tank. About 3/4 of that is robotically sprayed onto the outside of the tank. About 1/4 of that foam is applied manually. These ice frost ramps are applied manually. I have a scale model which perhaps shows even better. On the outside of the tank, looking at the tank in the vertical, we have the big 17-inch LOX line, liquid oxygen line, coming down to the right. And then we have the other protuberances. Remember we talked about the protuberance airload ramp. We have a cable tray that carries instrumentation from the bottom to the top of the tank. We have 2 pressurization lines, one for the hydrogen and one for the oxygen, that run from the engines in the Space Shuttle orbiter up to the top of those 2 tanks to keep them pressurized during flight. All of these things are connected to the underlying aluminum tank with metal brackets. And if that metal were uninsulated in the warm and humid environment in Florida, ice would form, and that would be unacceptable to us. So we apply foam to the outside of those brackets. Historically, we have seen as much as 2 or 3 ounce pieces of foam come off these brackets, these ice frost ramps as we call them. We have been trying very hard to come up with a shape that will not lose foam, but will at the same time insulate these brackets. That work is still ongoing. The decision that we had to come to yesterday was a question of whether it's appropriate to make more than one major change to the aerodynamic outer shell of the vehicle. When we came right down to it, the recommendation that I came to and provided to the administrator and to the associate administrator is that we're in a flight test program, classical flight test. If you look at aircraft or other experimental vehicles, when you make a major change, you should fly that major change without other major changes to see how it performed. And then if you have subsequent changes to be made, you make those in subsequent flights. The reason we had such an interesting discussion, and I would say it was not outside the usual kind of interesting discussion we have at our requirements board, is because there is a foam loss that we have seen and we will expect to see off of the ice frost ramps on the next flight. It is not without risk to fly these ice frost ramps as they exist. There was a strong concerted opinion from several folks that we should wait until we have a good design on these pieces of foam and then change them as well before we go fly. That is not without merit, and we considered it very strongly. However, at the end of the day, we came back to the fact that it is more appropriate to make one change at a time, to take care of the biggest problem that we have, and then work our way to the next situation that we'd like to improve. And I expect that will be the story of the external tank for the remainder of the life of the Space Shuttle program. I surely hope and plan that the next vehicle that we as an agency make will have eliminated this kind of concern in its basic design, and we won't have to worry about it. Clearly they will have plenty of challenges as they go onto the moon that will involve risk decisions in the future as well. So at the end of the day yesterday, the decision going forward was to fly, leaving these ice frost ramps as is, knowing that we will expect to have some small foam loss that could pose a risk to us, occur during the next flight or maybe two, while we continue to investigate how well our major aerodynamic change performs, and then we'll proceed to deal with these smaller areas of foam loss. That's about all I have to say, and I'll ask if anybody else has an opening statement or if we're ready to go to questions.
First.
I think Wayne's covered it really well. I think he described the discussions that we got a chance to hear and see the work that the team has done over this period of time. I think it's a real tribute to the team that's pulled this work together. You know, we started kind of last September with this overall plan of where we were going to do this testing and when the analysis was going to be complete. And through that entire period, all that work has been accomplished by the teams pretty much on schedule that allowed us to have this meeting yesterday to make this decision. So if you look all the way back from September to where we are today, the teams have executed that plan through lots of problems. The hurricane didn't help with all that, but the teams worked through all that stuff. They continue to do a great job to bring us a good set of data yesterday. A tremendous amount of wind tunnel work has gone into this. I can't stress how hard they've worked in getting these wind tunnel tests done. They're not easy to run these wind tunnel tests. It's not easy to understand this data. The team did a phenomenal job to get all this stuff together in as clean a format as we could hear yesterday from the team. So it was really a tribute to see this team perform and get ready to make a tough decision, but to get all the data together in place took multiple months and took a lot of personal work from a lot of folks. And I'm really proud of Wayne and his team for doing this activity.
I've learned not to ask Mike if he has an opening statement, so we'll go ahead and go straight to questions and answers. We'll start here in Washington, D.C. Again, I ask that you identify yourself and your organization before asking your questions. Then we'll go to other centers around the country. All right, we'll go ahead and start off with Guy.
Guy Gugliotta from the Washington Post, I guess, for Wayne. Does this mean that you have not, up to now, hit on a new design for the ice frost ramps that's an improvement over the old design?
We have been working very diligently, I should say the folks, particularly here at Marshall Space Flight Center, along with our Lockheed Martin contractors that build the external tank for us, have been working extremely hard to come up with a new shape for the ice frost ramps that provides both of the characteristics that we desire, which is to say does not form ice during the time that we're sitting on the launch pad with the cryogenics present, and also will hold together and not shed foam for any reason during the launch phase as we accelerate to supersonic speeds through the lower atmosphere. That is not an easy process. We do not have the perfect or final design in place today. There are a couple of conceptual designs. Great progress is being made. I expect in the next month to 6 weeks, we will come forward with a really good design that we will implement on subsequent tanks.
All right, next question. Keith.
Keith Cowing, SOS.com. For Wayne, I've gotten some really interesting feedback from people in and around this meeting. Some thought you were too conservative in making this decision. Some thought you were being risky. Some thought it was great that you finally just, have a process in place where you can listen to the hardware, so to speak, and just make a decision. Others thought that you didn't put the time into it. This has been a long path since you've been sitting in this position answering this question, but do you feel that schedule pressure is still there, or is it morphed into something that you can at least cut off in pieces and chew a little bit better?
Well, I'm mindful of the fact we just had a big project management conference in NASA, and I got reemphasized to us that a good project or program manager does have to consider cost and schedule along with the technical performance that he's trying to achieve, that the program or project is trying to achieve. In this particular instance, however, I felt that this was an important enough decision that we should divorce cost and schedule from this decision and make it on fairly technical grounds and then deal with the fallout. We have a schedule. It's important to have a schedule. We intend to complete the International Space Station in the next 4.5 years, but that didn't drive this particular discussion, and we are trying to make appropriate decisions in light of the schedule and not let it drive us to overly risky or foolish decisions just to make a schedule that we know has some time in it to allow for engineering problems to be solved.
All right, we'll take one more question here in Washington, and then we'll go to JSC. We'll go to Beth.
Beth Dickey with Government Executive. Given that you've now got one more foam issue to deal with after you fly the next flight, for any of the three of you, is this going to alter the plan to have 2 flights as a return-to-flight test, or might you add a third now?
Beth, we're going to take this one step at a time, and we currently have plans to launch the next 2 flights so that they have full daylight coverage so that we can get the best data back from the tank to see how the foam performed. We will make that decision following the next flight or 2 to see how we're doing. After that, we also have the radar, which is tracking any debris that might be shed off the vehicle. We made quite a sizable investment in considerable new radar that can do quite an interesting job of finding small things that come off the launch vehicle. And we have new cameras that are oriented in the direction where some people believe at least, that the light from the solid rocket boosters would provide sufficient illumination to still have good visual evidence through what we call first stage, the first 2 minutes of shuttle flight, to see what is going on. So we're going to see where the data leads us. Obviously, it is in the interest of getting on with space station assembly to be able to return to night launch operations, and that's where we'd like to get, but we'll measure that 1 flight at a time.
All right, let's go to the Johnson Space Center in Houston for a couple of questions.
This is Mark Carreau from the Houston Chronicle. Could you explain the number of ice frost ramps that are really on the tank, and how many of them, if not all of them, that you're really concerned about?
I hate to say it, but here in Huntsville, we could not hear the question. It was very low.
Sure, I'll repeat the question. Wayne, the question was, can you explain how many ice frost ramps are on the vehicle or on the external tank, and what the...
how many of those are you concerned with?
Yeah, and how many of those are you concerned with?
Ken, I brought him to the press conference. We need to let him answer one question. So, Ken, I'll let you take that.
Okay. There are a total of 34 ice frost ramps on the external tank. There are, I believe, 12 on the liquid oxygen tank and 16 on the liquid hydrogen tank. and I believe the balance is on the inner tank. The main concern that we have from a debris standpoint turns out to be about the top 4 on the hydrogen tank. These are in a area where thermally they warm up as the liquid level drains from the tank during the time of flight when debris poses a risk to the shuttle. So obviously we're concerned about foam loss from all of them, but those are the ones that are primary concern for us.
All right, Mark. Next question from Johnson.
This is Mark. I'm sorry, we didn't hear anything, but let me ask a follow-up. What is the expected mass and available mass of foam mass that you're going to work with on this next mission?
That sounded like Charlie Brown's teacher asking a question. I think we may have to repeat that one. All right, we're going to come back to Washington and see if we can work out some of those bugs of those questions. We'll go to Jeff Morris over here.
Hi, Jeff Morris with Aerospace Daily. I guess for Wayne or Ken, if you said 2 to 3 ounce pieces historically of foam have been observed coming off, I was just wondering what is kind of the worst case scenario of damage that a piece that size or maybe multiple pieces could do?
Our aerodynamics folks and the material science folks tell us that the worst case, if it came off with the maximum mass, which would be in the order of 3 or 3.5 ounces, and comes off at the worst time and follows the worst possible trajectory to the most vulnerable part of the orbiter, it would not be what we would like to have. I don't know how to characterize it more than that. It would cause what we call critical damage. So our goal is to eliminate or mitigate, thank you, that's the word I was thinking, mitigate that hazard to the maximum extent that we possibly can. And we intend to do that. And you know, once we deal with the ice frost ramps, then we're going to move on to the next area of the tank that we're concerned about that's potentially shedding even smaller pieces and work on that one. So this will be a continuous improvement process throughout the life of the program.
All right. Now we're going to go to the Marshall Space Flight Center where Wayne is to get a couple of questions.
Hi, this is Shelby Spires with the Huntsville Times, and this question's either for the administrator or Wayne. Wayne, you mentioned that you're committed to finishing or completing the International Space Station, but given that there's 3.5, 4 years left, do you think you'll make the flight rate? Is that flight rate that's been reported of 16 to 18 flights doable, and is the 2010 date still the retirement date for the shuttle, or is that a solid date?
Well, I'm going to take the easy part of that first and tell you that, yes, that number of flights in the next 4.5 years is eminently doable and well within the kind of flight rate that the shuttle has provided the nation before. So I'm very optimistic that we can complete the International Space Station in the time that we've been asked to do it. And we will have to be very diligent in looking at this aging vehicle and make sure that it's safe to fly every time we get ready to go fly it. But I think we have the resources and the capability to do that.
And I'll pick up my piece of that. Short answer is yes, 2010 is a firm date. Let me expand a little bit on the reasons for that. If this program, if the Space Shuttle program were of a nature that it was dominated by the variable cost of flight, the cost of flying each individual flight, then the right thing to do would be to plan a certain number of flights for budgetary purposes and execute that number, because then we would have known budgetary requirements and we would be done. But this is a program whose marginal cost of flight is actually quite reasonable, but for which the fixed costs of ownership are quite high and variously known to be around $4.5 billion a year. So we at NASA, we in fact in the federal government, cannot do budgetary planning for this program unless we pick a date when we will be done with it. We have to pick a year that will be the last year we will fly shuttle flights and stick with that. And that's what we're doing. And those are the reasons.
All right. Let's come back to Washington here. See if there's any follow-up questions. Let's go to Guy.
Guy Guglietta again from the Washington Post for Wayne. How has the removal of the power amp affected the performance of the ice frost ramps, if at all?
That is exactly the kind of question, not just the ice frost ramp performance, but all the other areas of the external tank, and in fact the integrated stack with the orbiter and the solid rocket boosters on it that we are looking at. Clearly there are increased aerodynamic loads and some structural elements. In particular, we talked about the protuberances that the power ramp was put on there to provide some aerodynamic relief from. So the principal things we are concerned about is the cable tray and the attached brackets that underlie that cable tray and how they fit under the skin of the tank, and these two pressurization lines, and in fact the big 17-inch liquid oxygen line as well. So that is exactly the kind of analysis that's going forward to demonstrate both in wind tunnels, computational fluid dynamics, and structural analysis that those parts will hold together under increased load, because without the power ramp there will be increased loading. And in fact we are looking at the whole integrated structure, solid rocket booster attachment points, the orbiter, and all other areas to ensure that we have not introduced some unanticipated consequence that would be untoward. So the performance of the overall vehicle has got to be satisfactory from a mechanical and structural standpoint. That we have yet to complete the analysis on. In terms of other performance, the good news is that's about 37 pounds of weight that we no longer will be carrying to orbit, that we can devote to additional supplies to the International Space Station, for example.
Curtis, you want to follow that?
To that, in the discussion I listened to yesterday, is we're really kind of pushing the state-of-the-art of our analysis and wind tunnel capabilities throughout the country. There's not really one wind tunnel where you can simulate all the proper conditions that are going on with the tank. There's not really one test facility where you can simulate all these things that come together in a shuttle launch. The tank expands when it's pressurized, it contracts when it's cooled down. The vibration from the solid rocket motors cause vibration through the tank structure, which go through these bracketry. Those press lines that Wayne showed you, those have fluid or gases flowing through them. They're moving up and down. They're dynamically moving in and out. All of that is tremendously difficult to simulate in our test facilities and to put together in computational flight dynamics. So at some point, you really need to go to flight, and you need to go to flight with some instrumentation so you can monitor that performance and see how the device and the design you put together with the best of your engineering capabilities actually performs in flight. And that's exactly what we're doing here. We're going to have some new cameras on the solid rocket boosters that we can look at these areas. We should be able to see the ice frost ramps. We should be able to see the small foam liberation that we expect to see come off. And then that data is going to be invaluable to go back and improve our wind tunnel models, improve our computational fluid dynamics, and take a piecewise incremental step in the improvement in the design. So we continue to monitor on each flight. We take all the data we can get from the flight. We put it together with all our ground assets. We make the best decision, and we move incrementally better on each flight.
Zach or anybody else up front that wants to ask a question? All right. Well, it looks like we are going to be wrapping up a little earlier today. We do not. So thank you for asking, Mike. Any closing remarks from Wayne?
Just that we're continuing to work toward the July 1st launch opportunity. We have a huge amount of work ahead of us, but we have a good plan, I think, and we have many dedicated people that are working very hard here at the Marshall Space Flight Center, Kennedy Space Flight Center, Johnson, and the other NASA centers around the agency have really stepped up to help us. Particularly want to thank the folks at the Arnold Engineering Laboratories, as well as Glenn Research Center and Ames Research Center, where we've been doing all this wonderful wind tunnel testing and using the supercomputers at the Ames Research Center to do our computational fluid dynamics work that makes all of this possible for us to feel confident when we go flying.
Thanks, Wayne. Gers? Nothing to add. Okay. Mike?
Yeah.
All right, well, that's going to conclude today's Space Shuttle update. I would like to remind folks that at 2 o'clock Eastern today, we're going to have the Exploration Workshop Media Telecon. I think, Mike, you wanted to mention a little something about the Exploration Workshop that's been going on?
Yeah, I haven't been able to attend it, but I keep getting reports that people who are there are really pretty happy with it. This is our, following the release of our architectural blueprint, I guess I should say, for returning to the moon. This is the first major conference or major event we've had where people can gather together and get to the interesting stuff, which is what do we want to do when we get there. When we don't have the transportation capability, which of course is where we are right now, all the focus has been on recreating the lunar transportation system that we once had, and doing so in a manner that will allow us to have the maximum transferability to Mars later on. And I think we've done that. But the really interesting part is, what do we do when we get off the Earth again for the first time in decades? And that's what this conference has been devoted to. And we've had folks from industry and folks from other countries and folks from the program out there, and I'm looking forward to hearing how that went at 2 o'clock myself.
That'll be great. Deputy Administrator Shanna Dale, along with Exploration Systems Mission Director Deputy Doug Cook, will be the participants in that media telecon. So we invite everybody here, certainly here and out at the centers, that want to take part in today's telecon, which will also be streamed on NASA.gov. All right, that's going to do it for today's Space Shuttle update. We thank you for joining us, and have a great afternoon.